Okay, so real quick, angle in standard position basically means that you draw the angle using what you've learned, which is basically you start with, at this particular juncture at 0 degrees, and you move up, in this case 18 degrees for the first part, which puts you exactly in quadrant 1. Remember the quadrants are quadrant 1, 2, quadrant 3, and quadrant 4. Alright, so for this answer choice will be B. For the second question, you have negative 39 degrees. So again, remember that the idea is because it's negative, you're going to go down 39 degrees, which means this is 39 degrees here, putting you at quadrant 4. Alright, so your answer choices for numbers 1 and 2 respectively are B and A. When you look at classification, this just goes back to basic definitions. Anything over 90 degrees we consider in this case obtuse, and so it's not acute, it's not straight, and it would not be right. If it were right, it would be exactly 90 degrees, so then answer choice would be C. And see what happened here. Bear with. Okay. Yeah. Alright, and so for this next one, 23.01 degrees, we're definitely using an acute angle in this case, so that's acute A. Alright, for this one, it says the radian measure of the central angle of a circle of radius r that intercepts an arc of length s, and so they're giving you r, they're giving you s, and so we know that by definition theta is equal to s over r, which is equivalent to 4.93 divided by 1.7, you get approximately 2.9 radian. Okay. Conversion of angles to degrees and degrees to radian respectively. Just remember, if the angle is up here, the 180 is going to go below it, and the pi will stay up here, and so that therefore when you reduce 60 over 180, you get 1/3, which is basically 1/3 pi radian. Same thing for number 7. Number 7, you have negative 54 degrees. So you're basically going to take negative 54 degrees, and remember the 180 goes below it because that's the degree, and the pi on top. In that case, pi over 180. When that reduces, you'll end up with this as a value. Last one, convert the angle in radian to degrees. So in this case, you have 11 pi over 2 basically, and so you always put the pi opposite the other one. So if the pi is in the numerator, you bring it down here and the 180 goes up top. When you do the math here, you end up with 990 because 2 goes into 180 90 times, and 11 times 90 will give you 990. Now, drawing the angle in standard position, again, same thing. You're basically taking the angle using the quadrants, and you are positioning the terminal side of this particular the value. And there is a cheat method which I'm going to show you, and you basically can transform this by multiplying by 180 over pi, and I believe you get 315 for this angle, and you end up with the terminal side over here. So that means that this angle goes like this, right? It's in standard position and it's drawn, and that's all they want there. Alright, and the same thing applies to the rest, no difference there. These 3 questions I'll come back to. We did them in class, but I guess I can work them out real quick. The key to number 12 is to transform this to radian. So you say, okay, well then 20 degrees times pi over 180, and you end up with 1/9, which is basically pi over 9, and you multiply that by 25 inches. When you do the math, remember this is in inches. When you do the math, remember that this is 3.14, so it's equivalent to 1/3 divided into 25 as a rough estimate. And all you need to do at that point is say, okay, well then pi times 25, which gives you approximately 78.5 divided by 9, is approximately 8.73. And so in this case, since we want 2 inches, or 2 decimals, that's our answer. Alright, and then this one, the inches, I know I was going a little quick on this one, but basically you're going to do, in this case, 60 degrees divided by, okay, so 60 inches divided by 16 inches, which gives you approximately 3.75. And we're going to multiply that then. Alright, and I believe that once you get 3.75, since the car wheel has 16 inch radius, through what angle to the nearest tenth of a degree does a wheel turn when the car rolls forward? So let me see, I have a little bit of a calculator issue here. We should get 214 and change. Bear with me. Yeah. So the 375 divided or times 180 degrees, technically over pi, because we're trying to answer the question here to the nearest tenth of a degree, so we got to convert this. So this ends up giving you 214. There are some decimals. I might be off on my decimals. Sorry, I might be off a little bit on my decimals because I rounded the 3.14 because I'm trying to be quick. Just estimated. You guys have the answer. And you'll be able to get the exact decimals. Okay, for this next question, the carousel question, just remember, basically you have a radius of 18 feet. A carousel is a circle, basically, and the circumference of that circle will be 2 pi r, which in this case is 18 feet. So when you do the math here, you end up with 2 times, again, I'm summarizing at the 3.14. We know that if you use the actual pi symbol, which is what I recommend, is what you should do. Okay, so when I do this part, I get approximately 113.04. And we're going to essentially divide this by 31 seconds. Let's divide by 31. You get approximately 3.646. I'm going to round it to 365. And again, remember this is in feet per second, so we're looking at 2 decimals. Alright, number 15. Number 15, cosecant theta. So this is theta. Cosecant, since I know that this is the opposite of sine, or the inverse of sine, and I know that sine is y over r, so that means that cosecant theta is simply y, r over y. So we need to find r. We know that's the square root of 109. Okay. And so this is our r value. This is square root 109 over, if I had done opposite, so remember this is sine, so opposite sine would be 3. So in this case the y value is 3. Because remember it's so this would be y and this would be the h. Opposite over hypotenuse. Okay, for this next one, it's cosecant theta, so that's simple. That's just, we need to find this, which is the square root of 34. And since it's the adjacent side over the hypotenuse, we end up with 3 over square root of 34, but we need to rationalize that. So you multiply top and bottom by square root of 34, you end up with 3 square root 34 over 34. Which is answer choice B. Okay, for these angles, you just simply have to substitute in the values as indicated. And so I'm going to go up to number 20 on this one and then stop. So cosecant 160, cosecant of 60 degrees, here's 60 degrees. Obviously that's the inverse of sine, so if I were to do sine, I would have, again, this is just to, so it's opposite over hypotenuse for sine, so that means that in this case, Sine 60 would have been square root of 3 over 2, but in this case we want cosecant 60, which is going to be 2 over square root of 3, which you obviously have to rationalize. Over here, the next part is sine 45. So if I'm looking at sine 45 from either respective side, I'm going to look at opposite over hypotenuse. So this is going to be 1 over square root of 2. And so what I have is 2 over square root of 3 minus 1 over square root of 2. And what I'm going to do is rationalize each respectively. So multiply both by their denominator. So this will become 2 square root of 3 over 3 minus square root of 2 over 2. And now we crisscross the denominators as factors. So we would multiply 2 times this. This gives me 4 square root of 3 minus, again multiply, 3 square root of 2. And again multiply the bottom, 6. And that's your answer choice. Okay, you would do the same process for these next two. Let me erase some of this so it's not so sloppy. And I'll use that workspace. Alright, and so the next one we have, let's see here. Alright, so we have the cotangent of pi over 3. So first of all, pi over 3 is basically 60 degrees. So we have the cotan of 60 degrees, which is the, instead of tan, which is opposite over adjacent, this is adjacent over opposite. So I basically have 1 over square root of 3. Minus sine pi over 3. Sine pi over 3 is basically sine 60. Again, sine 60 would be opposite over hypotenuse. So that's straightforward. So this is basically minus square root of 3 over 2. If I rationalize the denominator for this side, I end up with square root of 3 over 3 minus square root of 3 over 2. Okay? If I also then build this up by 3 and I build this up by 2, I end up with 2 square root of 3 over 6 minus 3 square root of 3 over 6. And this top portion ends up in negative 1 square root of 3 over 6, which is answer choice D. Okay, let me do the last two here, 19 and 20, and then I'm going to stop this part of the video. So tan theta, as we know, is sine theta over cosine theta. Right? And so they tell us sine theta is 2 over 7 over 3 square root of 5 over 7, which is cosine theta. So keep, change, flip. So basically 2 over 7 times 7 over 3 square root of 5. The 7's cancel. And you're left with 2 over 3 square root of 5. But we don't like that. So we're going to multiply by square root of 5, top and bottom. And that's going to cancel. This is going to leave us 15 in the denominator, and that's going to give us 2 square root of 5 over 15. Answer choice B. Okay, and for this last one, we want the secant of theta. And using our Pythagorean identities, which, let's see. Yeah, we should end up with 4 over 3 in this case. If you, just using the identity, I mean, it's like not rocket science, people. Let me stop the video there, and I will continue with numbers 21 to 22. Yes.